Hi guys, this is Miss Gold. Today's lesson is Module 2, Lesson 9, Converting Between Fractions and Decimals. Your outcomes for today's lesson are students understand that the context of a real-life situation often determines whether a rational number should be represented as a fraction or a decimal. Students understand that decimals specify points on the number line by repeatedly subdividing intervals into tenths. Deca means 1/10. Students convert positive decimals to fractions and fractions to decimals when the denominator is a product of only two factors, 2 or 5. Students understand that every rational number can be converted to a decimal. Students represent fractions as decimal numbers that either terminate in zeros or repeat, and students represent repeating decimals using a bar over the shortest sequence of repeating digits. And finally, students interpret word problems and convert between fractions and decimal forms of rational numbers. Let's start with example 1. What is the value of the number 2.25? How can this number be written as a fraction or mixed number? Now notice in this number we have a whole number 2. So we know that the whole in my mixed number would be a 2. So let's separate this. We have 2 and I want to say this decimal, instead of saying 0.25, let's say it the technical way. So the technical way to say this is 25 hundredths. The reason I want to say it that way is that actually shows me how to write it. So 2 would be the whole, and 25 hundredths would be the fraction 25 over 100. So basically, we're going to write it like we say it. For part B, it says rewrite the fraction in its simplest form, showing all the steps that you use. So we want to simplify our fraction. So let's focus just on the 25 over 100. And what I notice here is that there are actually 25s in the number 100. There are 4 of them. Think of 4 quarters is $1. So I'm not going to break down the 25, I'm just going to break down the 100 into 4 times 25. So when I do this, we can cancel out the 25s. They cancel and become 1. This is not 0, that's a common mistake. And we're left with 1/4. So my final mixed number is 2 1/4. Part C says, what is the value of the number 2.025? How can this number be written as a mixed number? So let's take the same idea we did with the last one and break it up into 2 parts. So we have 2 wholes, and the technical way to say this is 25 thousandths. Now, if you need a refresher on place value, once we have the decimal, the next place value is the tenths place, followed by the hundredths, and then the thousandths place. So this would be 25 thousandths. So writing this as a mixed number would be 2 and then the fraction 25 over 1,000. So let's rewrite this in simplest form, focusing just on our fraction here. 25 over 1,000. If I break down 1,000, I know that there are 10 100s in 1,000, so 100 times 10. Well, we can break down 100 like we did in the previous one as 4 times 25, so this would be 25 over 4 times 25 times 10. And again, the 25s are going to cancel, and what I'm left with here is a 1 on the top and 4 times 10, which is 40. So my final mixed number here would be 2 1/40. Okay, let's take a look at example 2. For mixed numbers, simply write the whole number before the decimal, then just focus on converting the fractional part of the mixed number. So when I look at -2 1/2, I'm really only going to focus on 1/2. Now at this point, we should know that 1/2 is the decimal 0.5. So then I'm just going to add the whole value in front of it. So we have -2, and then we know 1/2 is 0.5, so this would just be -2.5. But not all questions are going to be that simple. So what we want to do is let's take a look at some more complicated fractions. For example, 3 over 20. What we want to do here is if you look back at example 1, it was easiest if we could take a decimal and say it so that we could write it just like a fraction. And all of those have to do with tens, hundreds, thousands, 10,000s. So what we're trying to do here is look at this fraction and say, is there a way that I could turn that bottom into a 100 instead of a 20? So in this case, I have 20. Well, I know 20 times 5 is 100. So let's take 3 over 20 and multiply it by 5. But I can't just multiply the bottom. If I'm going to do something to it, I have to do it to both the top and the bottom. So really, it has a value of multiplying by 1, because 5 divided by 5 is 1. So in this case, I get 3 times 5 is 15, over 20 times 5 is 100. So we would say this is 15 over 100, and so if we kind of work backwards, that would be 15 100ths. So as a decimal, this is 0.15. Notice the 5 is in the hundredths place, the 1 is in the tenths place. So we kind of always read this as the last number determines the number on the bottom here, or the place value. So this is read as 15 hundredths, and that matches our fraction. The same can be done with 5 and 4 25ths. Now notice, I'm only going to focus on the fraction itself, but in the end, I will have a whole number 5 in front of it. So if we look at 4 25ths, I can turn 25 into 100 by multiplying by 4. So I'm going to multiply the top and bottom by 4. 4 times 4 gives me 16. 25 times 4 is 100. And so this is going to be read as the decimal 16 hundredths. So 16 hundredths. And then don't forget that we have a 5 as the whole number, so instead of a 0, I'm going to have a 5 out in front. Now notice, in the next example, there's really no easy way to turn 30 into 100. If I multiply by 3, I get 90, and if I multiply by 4, I get 120. So we're not going to use this method here. We're going to want to do long division. So let's take a look at part B. So we just talked about an example where we could not easily turn the denominator into 100. So in that case, what we're going to have to do is actually do division. So if you recall, in elementary school, we talked about the approach of bottom out, top in. So I'm going to first turn my fraction into that form of bottom out, top in. And immediately what you're going to need to do, because these are all numbers that are fractional values, so they are less than 1. And notice the 9 on the top is smaller than the denominator of 12. So I know that this value is going to be less than 1. So let's start off by putting our decimal place by our 9, and then you're going to take that straight up here. So we ask ourselves, how many times does 12 go into 9? 0 times. And so what I'm going to do is move over a place value, and so I'm going to add on a 0 here, and then I'm able to ask myself, how many times does 12 go into 90? So if you need to, because we aren't using a calculator, if you need to, do some calculations off to the side, you can do that. So if I go through and figure out 12, 24, 36, 48, 60, 72, 84, the next one beyond that is going to be more than 90. So 84 is the one I want. And we get that by doing 12 times 7. So 7 times 12 is 84, and we're going to subtract that from our 90. We are left with 6. And so again, 12 doesn't go into 6, so I move over one place value and add a 0. 12 goes into 60 5 times. 12 times 5 is 60, so when I subtract, I'm left with nothing, so I know that 9 over 12 is equivalent to the decimal 0.75, or 3/4. For the second example here, I want to note that you are always going to ignore the integer or the whole part of your mixed number. So in this case, we're going to ignore the -3 for now and just focus our attention on 4 over 30. So again, I'm going to do bottom out, top in, place my decimal, and then go straight up with it. And again, you'll see 30 does not go into 4, so we put a 0 there and move over 1. How many times does 30 go into 40? Well, we know it goes in ones. 1 times 30 is 30. So I subtract and I get 10. So then I ask myself, how many times does 30 go into 10? Well, it doesn't, so I'm going to have to add a place value. How many times does 30 go into 100? And I know 30 times 3 is 90, so it goes in 3 times, and we get 90. So we subtract, and I'm left with, again, 10. And so I'm going to go through this once more, but I think what you're going to start to see is we're going to keep getting the same thing every time, and that tells me that this is a repeating decimal. So if we go through again, 30 does not go into 10, so I add a 0. 30 goes into 100. 3 times 30 is 90, and you see I'm getting that same thing over again. And so I can start to see here, this is going to repeat itself. So my final answer here is where I'm going to include my -3. So -3 and 4 over 30 is equal to -3.13, and it's the 3 that's going to repeat itself. So I'm going to put a line just over the 3 because it's only the 3 that is repeating. Let's take a look at example 3. Eric and 4 of his friends are taking a trip across the New York State Thruway. They decide to split the cost of tolls equally. If the total cost of tolls is $8, how much will each person have to pay? So looking at this problem, what I know is that we are paying a total of $8, and they are going to split it equally among them. Now be careful here, a lot of people would read this and make the mistake of dividing by 4, but it's Eric and his 4 friends. So that's a total of 5 people. So I need to do 8 into 5. Now what I would suggest here is you can do this one of 2 ways. We could break this up because this is an improper fraction, but probably the easiest way is to actually just look at this and realize I can easily turn 5 into 100 by multiplying by 20. So I'm going to multiply both the top and bottom by 20. So 8 times 20 is 160, and 5 times 20 is 100. Now notice, as I was saying, this is an improper fraction, so we can pull out 1 whole. 1 whole would be 100 over 100, and what's left is 60 over 100. So this part right here is 1 whole. 60 over 100 can be reduced. We know that we can cancel out these zeros, and so really I get 6/10. So as a decimal, that is a 6 in the tenths place. 1 6/10 is my final answer. So if I'm going back to the real world scenario here, if I'm given a word problem, I need to give a worded answer. So 1.6 is actually going to represent $1.60. So we'll say they each pay $1.60. Just before leaving on the trip, 2 of Eric's friends have a family emergency and cannot go. What is each person's share of the $8 tolls now? So in this case, we still have the $8, but 2 people can't go, so 5 people drops down to 3 people. In this case, I can't easily multiply 3 by a number to get 100, so we're going to have to do long division. So let's break this down. Bottom out, top in, so we'd have 3 out, 8 in, place my decimal, and then go straight up with it. So we say, how many times does 3 go into 8? Well, we know it goes in twice. 3 times 2 is 6. Subtract those, and I'm left with 2. So I ask myself, how many times does 3 go into 2? Well, it doesn't, so I have to move over 1 place value and add a 0. How many times does 3 go into 20? It's going to go in 6 times, and when I do 3 times 6, I get 18. And I'm left with 2. So same idea here. How many times does 3 go into 2? It doesn't, so I'd add a 0. So how many times does 3 go into 20? 6 times. 3 times 6 is 18. And so you can see we're going to see this pattern continue. So this is going to repeat. The 6s will repeat. Now here's the problem. This is a real world situation. We can't give 2.666666666 forever dollars. You would have to round it. So if I have 2.666 ... In terms of money, we can only go out to this place value. So I need to look to the next one to tell this one what to do. Well, 6 is greater than 5, so it tells this 6 to round up. And so we're gonna go with 2.67. Now this is money, so it will be $2.67 per person. Again, I'm giving the context of not only the money, but what it represents in the situation, $2.67 per person. In this lesson, you have learned that any terminating decimal can be converted to a fraction using place value. A fraction whose denominator includes only factors of 2 and 5 can be converted to a decimal by writing the denominator as a power of 10.